Solving problems by using equation is something humankind has been doing for more than 2000 of years. The usage of equation system has existed for almost as long, though it was during the 19th century a mathematician called Gauss first developed an algebraic method for solving them. Another mathematician should be mentioned is Sofia Nowoleńska. She was a Russian mathematician that became the first female professor by the Royal University in Stockholm. She was the one to develop the substitution method for solving equation system. Equation system has been used when two or more variables are unknown. As example, 2x plus y equals 15. It is only possible to solve an equation with two unknown variables with two equations and three unknown variables with three equations. This means that if you want to find out what x and y are, you need one more equation. For example, x plus 3y equals 15. This gives us the equation system 2x plus y equals 15, x plus 3y equals 15. Now it's possible to find out what x and y are. Here comes an example of problem when an equation system can be useful. You go to the market one day and you buy 2 chocolate bars and 1 lollipop. Your friend is buying 1 chocolate bar and 3 lollipops. You pay 15 Swedish crowns and so does your friend. How much does a chocolate bar cost?
So, here we've got two equations with two different variables in each. To be able to solve this, we have to translate these two equations into one with only one variable. By subtracting 2x on each side, we get what y is in terms of x. Now it is possible to get an equation with only one variable by replacing y in equation 2 with 15 minus 2x, which is obviously the same as y. So 1 in 2 x plus 3y equals 15. So instead of writing y, I'm writing 15 minus 2x and solving what x is. Now we know that x equals 6. By knowing that, we can easily solve what y is by putting in the value of x instead of the variable. So, x in 1. Y equals 15 minus 2x. So instead of writing 2x, I'm writing 2 and 6. So, y equals 3. The answer to this equation system is y equals 3 and x equals 6.
These are the equations we have from the beginning, and with the elimination method we're able to solve the equation of x and y. To get the elimination to work, we have to have one term minus the same term in the other equations. Since we have plus 2 in equation 1, we need to have minus 2 in the second one. And how do we do that? Easy, by multiplying minus 2 in the second equation. Then we get the equation minus 2x minus 6y equals minus 30. Since we now have minus 2x and plus 2x in one equation each, they eliminate each other and we only get the y variable left. and then we get the easier equation and can without problem solve the equation of y. Y equals 3. When we know that what y is, we can just put it into one of the equations and solve it as any other equations. And this term we put it in, when this time we put it in the first. X equals 6. Now we know how to solve a system of equations by the eliminating method. The answers are x equals 6 and y equals 3.
Now we have opened up GeoGebra, which is a free graphing program. We're now going to solve our equation system graphically. Each equation equals a straight line in the coordinate system. The value of the variables x and y are represented in the point where the two lines intersect each other. We start by putting in our first equation down here. 2x plus y equals 15. Press enter. Do the same with equation number 2, which is x plus 3y equals 15, and then enter. Do like this and press intersect. Mark the lines to get point A, which is the exact point where the two lines intersect each other. It is also the answer to the equation. So, x is 6 and y is 3.
Now we've got 3 equations with 3 variables in each, and to solve this we use the elimination method. At first, we have to eliminate one of the variables in equation 1 and 2, and to make it easy, we choose y. Watch how we do it by using the elimination as if you had only 2 variables. This gives us the new equation 4. 5x plus 4z equals 11 that only contains 2 unknown variables. After we've done this, we do the same with equation 2 and 3. First, multiply equation 2 with 2 to get 6x minus 4y plus 2z equals 0. So you can eliminate the variable y in these equations too. The new equation 5, 7x plus 4y equals 9, also contains only 2 unknown variables. After this, we can use equation 4 and 5 to make a new equation system with 2 unknown variables. Multiply the equation 4 with minus 1. So that we can eliminate the variable z by doing like this. By the equation 6, we can now find out that x equals minus 1. Now that we know the variable x, we can simply put the value in equation 4, x in 4.
And now you also know the value of the variable z, which is 4. And at last, let's put in the known value in, for example, equation number 3, x and z in 3. -1 plus 4y plus 2 multiplied with 4 equals 9. Now you also know the value of the variable y, which is 0.5. Our answer is x equals -1, z equals 4, and y equals 0.5. Hope you have learned a lot by watching this clip. Now you know how to solve a system of equations with the elimination and substitution methods. We even showed you how to solve it graphically. Good luck with your equations in the future.